The year was 2018, which actually, now that I think about it, wasn't really that long ago, but things are moving really fast and it's already time for an update. So earlier this year, we did a video about the first ever open source CPU architecture, RISC-V, in collaboration with Sci-5, the makers of the first ever commercial RISC-V hardware. And today we get to go deeper. So Sci-5 sponsored our trip down to their headquarters in San Francisco to see some early concepts of real hardware products that are being built using their IP. All the way from a normal SSD, like what you'd install in your PC or laptop, to a functioning media server. And it might not look like much, but buried under this mess of wires, as there so often is, thar be treasure. Let's start with RISC-V's benefits in a nutshell. One, it's brand new, which means that it sheds a lot of the legacy bloat that accompanies traditional processor architectures, making it both extremely scalable and extremely power efficient. And two, it's open source, which means no expensive licensing fees for the companies that use it in their products. It always comes down to money, doesn't it? But it has some problems. Even if you had an open source CPU architecture and you knew how to build a CPU, unless you're already VC backed out the butt and you can scrape together a minimum order quantity on the order of hundreds of thousands of chips, a foundry like TSMC or GlobalFoundries is very unlikely to even pick up the phone. That is where Sci-5's real plan for the future comes in. So today, if you, like you right there, need to build a custom chip for some reason. Let's say you want to build a microcontroller for a car or a smart thermostat. There's a good chance that you would need to build an entire team of people that specialize in chip design and manufacturing. Looks expensive. But check this out. In the same way that large-scale computing has largely moved from servers in a closet under the stairs to the cloud, where processing power, storage, and network speed can be ordered a la carte, Sci-5 has created the pizza ordering app of custom chip development. So you jump onto their website, select things like performance, memory size, the type of ports and interfaces that you want, and then as you go, it generates a block diagram for you in real time. Then you click build and it goes to a cloud instance that chugs away generating and verifying the processor that you defined. Then the next day, you can download the Verilog RTL and FPGA images that you can then program onto a board and you're ready to rock. It's basically self-serve. This is in stark contrast to working with a traditional IP provider where you might have to sign an NDA and hand over some fat stacks before getting anywhere close to actually testing your software on your custom chip. Now right now, Sci-5 Core Designer only works for the CPU, but in the future, they'll integrate third-party intellectual property like graphics controllers and allow customers to build an entire SoC through their web interface. And then if they want to take it a step further, they can even have the chips fabbed and delivered through Sci-5's partnership with TSMC. So the demo room then, finally. It starts with the Sci-5 FU540, the same computer that was previously running Quake in our office. Currently, it's actually doing something a little different. It's playing a YouTube video here, which might not seem that impressive, but this is more of a software compatibility demo. So the operating system that's running here is Debian Linux with no RISC-V special expertise required in order to use it. Now it's the daily update stream, so you can expect frequent updates, but if you wanted to install some random application, let's say Firefox, you just apt-get install. To be clear, no one at Sci-5 is trying to convince average consumers to run out and buy one of these boards and run it at home. Outside of software from the package manager, very little will run at this time. Don't expect to download Steam and start gaming or whatever. But the message here is that compatibility is improving. About 94% of the packages in the Debian repository support RISC-V, and other flavors of Linux are working as well, including Fedora, OpenWRT, and OpenEmbedded. And performance is improving too. So web browsing, yeah, it's actually super slow right now. Like, let's go ahead and go to our website. Oh boy. But the problem here is that the engine behind the browser doesn't have a JavaScript just-in-time compiler. So it's kind of like having a 10-year-old engine on a brand new car. With more optimization, that should get as much as 10 times faster, about equivalent to an entry-level quad-core ARM A53, which, as some of you probably realize, still isn't an overabundance of performance. If only there was some way to add co-processing capability to it. Oh wait, there is. So this demo right here comes courtesy of Microsemi, a microchip company. These guys build field programmable gate arrays, and FPGAs are expensive, but these things are really cool. So basically, they're hardware chips that you can program to offload certain workloads to hardware rather than software, allowing your device to perform a specific task, in this case, computer vision, really, really quickly. So their plan is actually to take this entire thing here and turn it into a single SoC that they're calling Polar Fire, marrying RISC-V's real-time Linux capabilities to their programmability with full cache and memory coherency. I'm gonna challenge this thing. Let's try a chair. What do you think? Can you do a chair? Oh, airplane? Wait, ah, there it is! I had it for a second there. Chair, woo! It's still early days, but hey, person, it's got person. Confirmed here first, Linus is a real person. Woo, woo. And it gets even more modular. The RISC-V Foundation includes some really influential members these days, including NVIDIA, who has one of their NVDLA deep learning accelerators running the YOLO, you only look once algorithm for object detection. So in a similar fashion to the last demo we saw, it pulls images from the webcam here, pushes them into the NVDLA's buffers where the object is detected, then it displays the results on the monitor. It's just a more powerful example of fundamentally the same idea. Let's see if it picks up the phone. Yeah, look at that. And this scalability goes down as well. So this is Sci-Fi's FE310 on a Hi-5 1 board. It's an embedded board that is physically compatible with Arduino, but with about 10 times the performance. So the demo we're looking at here doesn't look like much, but what we're seeing is that it can work on a computational task in the background and a real-time one, which is the blinking of these LEDs right here. So there is a performance penalty to our LED going off exactly on time, interrupting whatever else is going on. But for some applications, like medical, for example, key tasks need to be performed right now. And actually, this design across the table from Upbeat is targeting the Chinese fitness wearable industry and is expected to show up in future devices from Huami. It integrates a similar E3 series core, but with extra IP, including a CNN or convolutional neural network and a graphics accelerator. It looks really big, but this is just development stuff. It's right there. Cool, huh? Now this next station is a little more relatable for PC enthusiasts. We talked at considerable length recently about the complexity of pushing SSD performance up when NAND flash performance has gone down in recent years. It requires very high-speed controller chips, and Sci-Fi's partner Fadu is actually working on what they hope will be the fastest consumer SSD on the market, with a planned ship date of Q3 2019. So this here is a Fadu ASIC with 3 Sci-Fi E51 core IPs, so that's their 64-bit high-performance embedded core, and those are driving the SSD controller algorithms that do all of the page mapping and whatnot. And Fadu claims that the Sci-Fi cores were 1/3 of the power and area of competing designs. Now, we couldn't plug it in to verify any of this, it's still very early stages, but here's something we were able to plug in. In years past, this home media server or NAS device from WD would have had an SoC based on licensed ARM intellectual property hooked up to its shingled magnetic recording hard drive and then handling streaming media over your network to a device like this laptop. Well, not today. Now they're really far away from talking about performance at this point, but the demo that you're seeing is running on real RISC-V silicon with the cost savings that come with it, and they're hopeful that on top of a cost savings, thanks to a greater degree of control over the hardware, they could create custom instructions that improve the data path, increasing performance. Dang. Leaving us with just a couple of housekeeping items here. So one, Sci-Fi had not one, but 3 debugging tool partners demoing their wares, including IAR, Sager, and Lauterbach, and had a couple really cool security demos. This secure boot demo checks for a properly signed Linux image, and if everything's fine, it boots normally, but if something's amiss, this light goes off. Wait for it. Ah, there it is. Bad evil Linux. Cannot boot Linux, authentication failed. Now, obviously this is not how it'll actually work in the real world, but it's very cute. And then over here, we have the Hex5 multi-zone demo. So the Sci-Fi processor is running this motor control, a console, and a real-time program that's making this LED blink, and each of them is in its own bucket. So the idea here is that if the LED blinker were to get attacked, it can't turn around and in turn attack your motor control. Which basically concludes our portion of today's exercise, but you guys still have a homework assignment. And this is pretty cool. If you've ever even thought that chip design is kind of cool, go to Sci-Fi's site and fire up their core designer. Just give it a try. I think you guys might be impressed at how cool it is, even just as like kind of a fun learning tool to look at what components there are to a CPU if you've never really given it any thought anymore. We're gonna have that linked in the video description. So thanks to Sci-Fi for sponsoring this video. Thanks to you guys for watching it. If you guys disliked it, you can hit that button, but if you liked it, hit like, get subscribed, or maybe consider checking out where to buy the stuff we featured at the link below. Also down there is our merch store, which has cool shirts like this one, and our community forum, which you should totally join.